Now let's answer this second easy question and let's see how it goes. Find the obtuse angle between the directions of the two lines. You see, between the what? Directions. Between the what? Directions. Now, what is the direction? Where is the direction? It is this second part. So are you telling me we use direction again to find angle between two? Yes. Oh my goodness. The same thing that we used to check if the lines are parallel? Yes. The same thing. You use the direction, the second part. That's the one. Because look, here's the formula. We actually say, this is the formula to know. There's a formula and then you're going to use this. So we say cos theta is equal to A dot B over the modulus of A times the modulus of B. This will give you cos theta, and it will have, the theta will be obviously the angle between the two vectors. So to get theta, what is it? This is how you do it. Now, how do you get A dot B? A dot B is just you multiply the x values, you add to multiplication of the y values, you add to multiplication of the z values. Okay, you'll be adding those. Now, to get the modulus of A times the modulus of B, you'll be just getting the modulus. You square and then you add and then whatever. Then at the end, you'd get the square root, and then that's what you do until you get theta. So let's see how it is. It's so easy. Cos theta is A dot B over the modulus of A times the modulus of B. Let me go show you in MF19 under vectors where this part actually comes, this formula. I'm going to go to MF19 and we go down to the vectors part. Okay, and our particular focus is here on what this is. This is just in a different version. It is saying that A dot B, which is this is how you get A. You just multiply the x part, you add to the multiplication of the y part, you add to the multiplication of the z part. But remember, it's only the direction part of the equation. So we're going to say A dot B is equal to the modulus of A times the modulus of B times cosine of theta, right? This is what they're saying, which obviously will make cos theta the subject by taking the moduluses to the other side. You'd have A dot B over the modulus of A times the modulus of B is equal to cos theta, which is the one I have given you, Cos theta is equal to A dot B over the modulus of A times the modulus of B. That is what you're doing when you are looking for direction. And remember, let's do it now. We're going to find it in, sorry for this. You're going to find it in parts. Let's do that. So we're going to say, okay, what is my A dot B? This is going to be equal to, you multiply the x thing. So what you do is when you're dealing with vectors, you look at the direction only when you want the angle between it. It's 2, 3 minus 1 and then minus 1 minus 2, 1. So you have 2, 3 minus 1 and you have minus 1, 2, 3 minus 1, and the other direction minus 1 minus 2, 1. So it is minus 1 minus 2, 1. These are the two things. So you're going to say that A dot B, this is just going to be equal to multiply the x values, 2 times negative 1 plus 3 times negative 2 plus minus 1 times 1. Okay, minus 1 times 1. We are going to get a solution. 2 times negative 1, that's negative 2. 3 times negative 2, that's negative 6. Minus 1 times 1, that's negative 1. This becomes minus 2 minus 6 minus 1. You're going to get minus 9. This is my A dot B. You multiply the x, you add to the multiplication of the y, you add to, remember you add to the multiplication of the z. That's how you do it, adding to the multiplications. You understand? This gives us A dot B. Then you're going to say, what is the modulus of A? This is going to be equal to the modulus of this first one. This is going to be square root of, you say 2 squared plus 3 squared plus negative 1 all squared. Then what is the modulus of B? This is equal to the square root of minus 1 squared minus 2 minus 1 all squared plus negative 2 all squared plus 1 all squared. Then you're going to do this. This is going to be equal to 2 squared, that's 4, whatever, let's put it. Square root of 2 squared plus 3 squared, then plus negative 1 or negative 1 all squared. You do square root of this. It's going to be square root of 14. Then this is equal to, what is the square root of this other one now? Square root of minus 1 squared, we have it. Then square root of minus 2, then of 1. So square root of, this is actually negative 2 all squared. Then this will be a 1 squared. This will give you root of 6. Are you seeing this? So now we are going to say, you can come and put the formula again. Say cos theta is equal to A dot B over the modulus of A by the modulus of B, which is equal to A dot B is what? Negative 9 all over these two moduluses, root of 14 times root of 6, which is negative 9 over, what is 14 times 6? This is 84. So it is all over the square root of 84. This is going to be my cos theta, which means I'm going to say that theta is equal to cos inverse of, I don't even need to try simplify, negative of 9 over root 84. So I'm going to say now, second function cos, and inside here I'm going to say of, I start my fraction, is going to be negative 9 over square root of 84. And what am I going to get for this one? I'm going to get it being theta being equal to 2.95 rad. Okay, I don't want it in rad. Let me change it to degrees. Let's see. This is equal to 169 point whatever. So here I have 169.1 degrees, because they said for degrees I put to 1 decimal place, and this becomes my theta. Is this hard? I don't think it is hard. This is just so easy. This is how you're going to get your angle, and you would be done and will say, so my goodness, this is so good, you did very well. So it's 169.1 degrees and you're done. This is how you get the angle. Remember, you look at the directions, okay? And then again here you see how you saw how you check for whether they are parallel or not, and then you get the XYZ. You check. Okay, remember to change the R to be XYZ. So the R will actually change to be XYZ and another XYZ. Then you make X equal the Y equal the Z equal. Then you pick any two, you solve the way you want to find mu and lambda. And then you're going to try them into the third one, and you see if you get the same value on both sides. If you can't, they do not intersect. And if they were not parallel and they do not intersect, obviously these two lines are skew. You would have proved. Anyway, now we are going to the next thing. Goodbye for now. We meet in the next video where we talk about number 7, and let's see how it goes.